Hello, geometry students. Welcome back to another video lesson, 5-4, Proofs using the transitive property. So we've been working on this transitive property idea for the last couple of days. We've been working on alternate interior, alternate exterior, same side interior, corresponding angles. So we've been working on all of these angles formed by transversals. And really what it's allowing us to do is create this transitive property that we can use as a justification in a proof. So today I want to take you through three examples, to just help you figure out how do we set these up and what are we looking for as justifications in each of these steps. Okay, so 3 examples, and then we'll practice on them on our own. Example 1, we are given that line M is parallel to line N. Okay, we're given these 2 lines are parallel. So let's just mark that up quickly. I know they're parallel. Boom and boom. They're asking us to prove that angle 1 is the same or congruent to angle 7. Go through the steps to prove that. Now, what you might see a little bit on the test is giving you the conclusions on the left-hand side and asking you to write the justifications along the right-hand side. Obviously, as I hope we should know, we always start with the given. M is parallel to N. If M is parallel to N, what allows us to conclude that the angle 1 is congruent to angle 3? What allows me to say those 2 are congruent? Well, hopefully you remember that those are vertical angles. So that's the vertical angle theorem. All right, if angles are vertical, they have to be congruent. So that's the vertical angle theorem. Then they go, all right, well, since I know that I've got an angle 3 now, I also can conclude that angle 3 is congruent to angle 7. 3 is congruent to 7. What allows us to say that those 2 angles are congruent? Well, those 2 are corresponding angles. So we've got the corresponding angles postulate. Remember that if 2 lines are parallel, then corresponding angles are congruent. Line M is parallel to N. 3 and 7 are both in the bottom right of their group of 4. Bottom right. So because they're corresponding angles, they have to be congruent if those lines are parallel. Now, they jumped from 1 being congruent to 3 and 7 being congruent to 3. And they say, let's cut out the angle 3 and just tie them all together to say angle 1 is congruent to angle 7. Right? Angle 1 congruent to angle 3. Angle 3 is also congruent to angle 7. Well, what allows us to cut out that middle person? That is where we use the transitive property. The transitive property really allows us to tie those 3 pieces of information together because they have one common piece. They both are congruent to angle 3, so they must be congruent to each other. And that's how we can set up a proof. And again, you'll have one probably on the test that looks something like this, where it gives you the information over here, and you've got to justify each of those steps. So go back to what we've learned and what you've used on justifications. Example 2 gives us this diagram and a blank proof to complete. We are given that segment AB is congruent to segment BC. We're also told that segment BC is congruent to segment CD. We want to prove that AB is congruent to CD. What should we always start with? For number 1 on the conclusions and justifications, what should we always start with? I sure hope, we've talked about this a lot, that you remember we start with the given. So we just rewrite it. AB is congruent to BC and BC sorry, this is getting a little sloppy, is congruent to CD. Right? So AB is congruent to BC, but BC is also congruent to CD. Well, if you notice, right, AB is congruent to BC, but BC is also congruent to CD. They are both congruent to the same thing, BC. What allows us to cut out that middle chunk and go right to saying that AB is congruent to CD? What allows us to say that? That's called the transitive property again. Notice we're using this a lot right now to try and understand what it looks like. The transitive property, two pieces are tied together because they share one common piece that they are both congruent or equal to. All right, that's that transitive property. Going to give you one final example. Pause the video here, 2 steps. See if you can't figure out what's happening in these 2 steps. Give me the conclusions and give me those justifications. All right, welcome back. What do we always start with? Yeah, we start with the given. So now Kg equals Gp, and Gp is equal to Pt. What's the justification here for number 1? It's always given. No matter what, fill that in. That's at least half a point probably every time if you fill that part in, given. Now notice, we're trying to prove that Kg is congruent to Pt. They are connected. They have a common piece, Gp. They're both equal to Gp. So we can cut out Gp, or we can deduce that Kg must be equal to Pt. They must be equal because they have a common segment, Gp, and that's, again, the transitive property. So the transitive property is our last justification. So I just wanted to take a little bit of time today to walk you through a couple of those, give you some familiarity with them, and prepare you for an upcoming test. You'll have a couple of practice problems today out of the, it's going to be a worksheet. Make sure you try them, do your best. If you have questions, make sure that you do indeed reach out. Until next time, everyone, stay safe.